Hello everyone and welcome back to Microtech Knives. I hope everyone is doing well today. What we're going to do, guys, it's been a while since we did the birth of an Ultratech video, and we've got a lot of new people, a lot of new equipment, and we want to show you what the process is going from concept, idea to finished product. All right, so for those that might not be aware, we are a 100% made in USA company and we employ about 180 employees. We have 3 locations in North Carolina and 1 in Bradford, Pennsylvania. So that's a little bit about the background of the company. So what we're going to do is we're going to go inside and we're going to show you the process of how we come up with an idea of actually making a knife. First and foremost is going to be having an idea or having a concept. So when we spoke with the guys over at Surefire back in 2024, whoops, almost dropped it, they had the Stiletto Pro 2 that they were getting ready to release. So we didn't have a knife that actually fit the design of the Stiletto Pro 2. So what we wanted to do was emulate a knife that looked like it was made off the same tooling. It was basically tabula rasa, it was clean slate. We could do whatever we wanted to do, but it had to kind of emulate the design cues of the Stiletto Pro. So the first place that's going to start, it might be on a piece of paper, it might be on a napkin, but from there it's got to go to engineering. So first place we're going to stop is engineering. All right, so behind me here is engineering. We're not going to go in there. We don't show anything that's on the computers, but this is where that idea is going to start. These guys will work hand in hand with Tony usually. They'll come up with some ideas. So what we had to do was start with something that would emulate that stiletto. Now, once we come up with some ideas that we think might work, then it will go into the lab and we will do like a 3D model of it, 3D printing it, calling DMLS, whatever you want to call it. In the lab here, we will come up with some ideas. We're only going to look at this area right here because there's some other things over there we can't show. So some of the very first ideas were done out of 3D print. So this was actually how life started on this. Okay, so you guys can see how it came out close to the true product. But we'll have some ideas on the blades, blade types. Like I said, this is just a polymer, it's just 3D printed. You guys can actually see the kitchen knives here. These were some of the original prints for the kitchen knife for the culinary line. And then you can also see like the mini Hera here, which is just done in a clear. But guys, what this allows you to do is get it in your hand, feel it to make sure that there's no hot spots or anything that just doesn't work. So it gives us a way to see it because we don't want to start cutting chips yet. You know, when we start cutting aluminum, it gets very expensive. And so if we need to make changes, now's the time to do it. Because if we hold this and we say, man, that thing's got a really bad hot spot right here, we can re-engineer that before we actually put it into a program to go in the CNCs. So that's what we do here. This is a basic setup. We have some other ones over here. We're not going to show those because there's some objects that are in there that we don't want to show at this time. But that's how life starts, from that concept to getting something that we can hold in our hands. So what we're going to do is we're going to go downstairs where it's got to get coated before we can actually coat it, as in CODED, so that we can actually put it on the machine. So let's go downstairs and check that out. All right, so in this office here, there's nothing on the screen that I have to worry about, but this is where everything is going to get coated. Basically, you've got to tell the CNC how to cut this chassis. We're always going to start with the chassis and also some blade ideas. Okay, now those are going to happen in 2 different areas of the facilities, but what we have to do is get that coated first, and then we'll go out to this set of machines and we'll show you how that works. So when it comes to materials, you have a couple of different options. If it's going to be a Marfion custom, that might be done out of stainless steel, but if it's going to be out of aluminum like most of our other knives, we have to decide whether or not it's going to be like 60-61 aluminum or if it's going to be 70-75. Now, specifically for the luminary, we chose 70-75 for a couple of different reasons. So if you come over here, all of our stock we order out of the same batch because not all aluminum is the same and we don't want dissimilar qualities of aluminum, so it's all same batch material. So it's going to start as a piece of bar stock like this. So let's say it's 70-75. We'll actually have an operator come in and he will actually drill 3 holes, and this will actually go onto the fixturing of a CNC machine. Now somebody's got to design this fixturing. You don't just slap it up and it just sticks. So in order to do that on these machines, and I'm going to turn around, I'm going to walk over here so you guys can see it. You have to have something for this to attach to so that you can start your first prototypes. So this is called a tombstone or a pallet, okay? And so this is going to be for prototyping. It is not going to be the actual fixturing for actual production. But what we need to do is machine 1/2 of that chassis out. The other side, or the adjacent side, will have the bottom half of it. But you can essentially get somewhere between 12 to 16 full chassis, but that's going to take approximately 8 to 10 hours, depending on which chassis you're working on. All right, so while this is not a luminary, this is an exact example of what just came off the machine. So what started off as a bar will actually CNC the side. Now this is only a bottom cover, and then another part of the actual tombstone will have the top cover. So this will take about 9 hours to do, and there will be a mating top cover that go to this. So once this is done, these get broken off and basically gets reinserted back into the machine for the second operation, because this is the first operation. Once you do that, you will essentially, and I'm just going to show you guys this is MSI, you'll essentially have 2 halves that are mated together that go together, left side, right side, or top of chassis, bottom of chassis. Now, these are going to have to go to processing. That's very important, because when they come out like this, they have extremely sharp edges, and so we have to make sure that these get tumbled and deburred. But we don't just take it for granted that this machine did it properly. Once they come off of this strip and they get down into the actual top and bottom cover, they have to go to QC next. So let's go over to QC, check it out, see what all they do before it goes to processing. All right, so this is a coordinate measurement machine, otherwise known as the CMM. This has the ability to measure down to about 3 microns. It uses a ruby tip, and so basically you can touch probe to make sure that everything is right. We have all the fixtures set up for the different models, and they'll go through and they will batch test. You're not going to test each individual chassis that comes off of there, but they can batch test to make sure that we're good, so that we'll catch something every 10th round or so. Now, if you come back here into the actual QC department, this is run by 2 gentlemen. You have a vision system here, or vision machine, and then they can check out certain specs, sizes, relationships, but these guys are responsible for all of that. So right now he's actually comparing some chassis widths. He's using a set of vernier calipers, and he's looking at the actual print. We don't want to zoom in on that print or anything, but thanks guys. We're going to get out of your hair. All right, so from QC, everything has to go to processing. Processing is where we're going to do all of the tumbling and deburring. That is going to be this whole division here. What you're going to see are these rotary tumblers. They work off a carousel system. They're actually doing the servicing now, but basically they have a media that's going to tumble these chassis to get all those sharp edges and the machine marks off. So we're going to keep working our way around. We'll talk about some of this other equipment later. I'm going to step up on this platform here. But this is one of those chassis that's getting ready to go in, just like what you saw a moment ago. These all have travelers, so we can account for each unit. That way we have a matching top and bottom. So this is a tumbler system. You also have some drum tumblers over here. Let's go over here to the side. So processing doesn't just do chassis. They also have to tumble blades, all of the small parts. You guys can see some of the other tumblers here. For the really small parts, we use these tumblers. And once they do that, they've got to get cleaned, washed, and they're going to be shipped out to the anodizers. Now remember, we will not see those chassis or be able to do anything with them for about 2 to 3 weeks. But we're not going to sit around and wait for these chassis. Right now, everything returns on a cycle, so every week we'll have chassis coming in. Now, in the meantime, you still have other things that you can work on. So the chassis has been addressed, but now we need to think about not only the blade, but also the small parts, everything from the button to the glass brake, and that's actually going to be done on the CNC Swiss machines. We have our own CNC Swiss lathes. We use Tsugamis, we use Citizen Syncoms like the L20s, and they have bar feeders. So what I'm going to do is I'm going to show you how that works, because we're running a bunch of parts. We have to run them every day. But basically with an FMB bar feeder, this is what we're going to load into that bar feeder. So this will be round stock to make things like pivots for LUDT. It might be the T30 on the actual pocket clip. It might be a glass break. So what this machine is doing right now is it is actually making a glass break. You guys can see that. You'll recognize this from maybe the Scarab. And for this glass break, it still has to go through processing because this is straight out of the machine. All right, so we've talked about the chassis. We've talked about the small parts. All of these are running, but now we need to talk about the heart of the knife, and that being the blade. You guys know that we use Böhler M390, which is an Austrian super steel. MK is something that stands for Microtech knives, but in essence, it's truly Böhler M391, which is what is marked here. Now behind me, what we have is we have our Optiplex system. Guys, this thing is extremely powerful. It is a laser that will cut this with the utmost precision using a 4 kilowatt laser and nitrogen. And guys, when I say we go through a lot of nitrogen, it is a ton of nitrogen every day. All right, so when I say we make every part, we make every part. You guys might recognize this. Of course, it's cut off of the laser, but this right here will be a pocket clip that will be bent. Here's an example of the sliders internally. This is what the spring rides on. This is basically how you actuate an automatic knife. And so we're making all of our own sliders. While the laser can do some incredible things, the water jet can do some things that the laser can't do and vice versa. So we actually have 3 of these units. We have OMAX and we have flows. And basically you're doing underwater cutting with abrasives. When the company first started, for many, many years, all we did was water jet production. And then over the last year or so, we've been using the Mazak, and that's sped up production incredibly well. So this is an example of what comes off of that plate. You can still see that scaling from that plate steel. So to get that scaling off, this is going to get an initial surface grind. I'm just going to give you just a quick rundown of what we're doing with the surface grinder here. Basically, we're taking those blades, specifically those Ultratech blades, and they're going to go on this magnetic chuck. So this is a magnetic bed. You basically place it down, you get everything nested really well. These are individually placed, and you turn the magnet on. That's going to draw it down. What this bed does then is it takes little passes, and you're programming it in and out, as well as up and down, and the accuracy on this is incredible, okay? What we're trying to do is basically get that scaling off. We'll flip it, we'll get the scaling off the other side, and then now it's got down to that nominal thickness so we can go load it into the Burger or the Seatman for angle grinding. Still have a lot of stuff to do, and we'll show you that on part 2. So hopefully you'll join us in a week or two. Definitely follow us on social media, Facebook and Instagram. Hope you guys are enjoying the series.